logistic regression. Okay. Yesterday we learned about the linear regression, which is a part of the uh, regression under supervised learning. Now we will be learning about logistic regression, which is a part of classification under supervised learning. Okay. So by the end of the session, we will try to understand like what is logistic regression and where it is used, difference between regression and classification, sigmoid function and decision boundaries, model training and interpretation Python, and evaluating classification format. Okay, so let's get started. So what is classification? So just like that, just like earlier we learned about the linear regression in the previous lecture, which is basically work with the continuous values. This time classification, in which is a part of regression, linear regression, and this time in classification we do prediction of categories. Okay, here we do not deal with the numerical, we do not deal with the continuous values. For example, if I give you example, we go with, for example, there are certain fruits that we need to identify, and the fruits can all only fall into category of apple, oranges, and bananas. Okay, so these are the three categories. Now, if we have some fruit and we have to identify whether it is apple, orange, or banana, uh, so in that case, we are dealing with the categorical values or categorical data, because at the end we only have three outcomes. Okay, one is apple, orange, and banana. Okay, so this is what classification is. In classification, we learn about the we try to predict categories. Okay, for example, like you can see, as you can see on the screen, uh, it has various example like spam versus not spam. Whenever you like your Gmail, identify the whether the mail you get is spam or not. It's a part of classification, uh, classification machine learning. Okay, like disease versus no disease, whether customer will buy or not buy the product. There are only few finite set of possibilities here. Okay, uh, so it is it comes under classification data. Okay, so in that case, output is a label. Okay, whether it is even 0 or 1. It's basically called binary classification, in which we have only two categories. Okay, so and in the binary classification, the logistic regression is one of the most widely used methods. Do not get confused by the name regression. Uh, ac- Logistic regression is used for classification data. Okay, so let's get started. Why logistic regression? Okay, so first of all, it's simple and fast, works well with linearly separable data, but, uh, which means that the data that can be linearly separable. Like earlier we were using with linear regression, that was linear separable data. But in that case, what happened? That data can also be somewhat used for classification. So in that case, logistic regression would be a great help to us. And probabilistic output 0 to 1, because where we have the probabilistic output either 0 or 1. Logistic regression will very useful because it gives the output in between 0 to 1, so that we can like give it a threshold and can simply give it a threshold and it can easily be uh, classified whether it will happen or not happen, or spam or not spam, any other example if you want. And it is easy to interpret the coefficients in this. Okay, like earlier we uh, learned about the coefficients in linear regression, like what is the slope and intercept. Similarly, here also some coefficients we will be seeing then going ahead. And So it's easy to understand in the case of classification. So that's why logistic regression is used. Okay. So it is used in healthcare prediction whether the patient is having a disease or not, financial risk scoring, marketing conversions, etc. Okay. So what is the core of uh, logistic regression? Uh, is some works on the same principle of linear regression. Okay, that's why regression word is there. Okay, but what is the thing that makes it different from linear regression? So it is the thing is the sigmoid function. Okay, so what it does is it converts any value into a probability between 0 and 1. Okay, it is a function that can be used. Suppose if you get any output, it can easily convert it to value between 0 and 1. And formula, as you can see, formula on your screen is 1 upon 1 plus e raised to power minus x, where x can be your input variable. Okay, so here in this part, we decide the precision threshold, in which most of the time we will say 0.5. Okay, if the probability comes greater than 0.5 after applying sigmoid function, it belongs to class 1. And if it doesn't, it becomes a class called 0. Okay. The shape of the graph you can see in the screen, this is a sigmoid function here, somewhat S mapping. Okay. It is somewhat, as you can see, like some kind of slide or S usually referred to it. Okay. So this is a sigmoid function. It is the main core differentiating factor between logistic regression and linear regression. Or you can say it is it is the reason why logistic regression used for classification. Okay. Now, what is the workflow here? Okay. In this, we will like collect and clean data set. Simple part of the ADA. Perform feature selections. Like what feature do we need for the model to be able to predict the output. Split it into training and test data, just like we did in linear regression class. Fit logistic regression model. Simple here. We have to just like we fitted linear regression. We will now fit logistic regression model, predict the probabilities, convert probabilities into class labels, and evaluate with accuracy, precision, recall, or F1. These are the like performance metrics in the case of classification. In the case of regression, in the last lecture we did R square score. In this, we will use accuracy, precision, recall, and F1 score. Okay, so let's get started. This is some like 70 to 80% similar workload as to linear regression, and this 30% we will uh, code something new here. Okay, so let's get started with the code. Here I just this is the data that we will be working upon. It is a heart disease prediction data. Okay, so I've already imported data and do some transformation. Just you can it can be you can just ignore it for now. Okay, so we will be starting with uh, our let's check data first. Is null if there are any missing values in that. So as you can see, there's no missing value, so we can go forward and split the data for our training and testing. Okay, so as you can see, this whole data is in like numerical form. So let's get started. Let's take our x variable, and either I can write like all the columns here, and just give it a name. Or there's a trick that you can do. Use df.drop df. Just remove the last two columns. Okay, and you will get the your X data set. Okay. Mm, and Y we will have df dot disease. Okay. Heart is not found in access. What is the problem? Okay, I think I do not need to put here. Let me check like if I'm giving the column name wrong. Heart disease not found in access. Let me that again. Okay, I have to give the access. Okay, okay, okay. Yeah, access is also important. It will know like from where it has to drop. Access one is equals to means column. Now just for verification, yeah, we got all our columns for the training. And now what will we do is to split the data set. Split the data set. Okay. From like we did earlier in the previous lecture, from sklearn.model section import train test split. Okay. From here, x train comma x test comma y train comma y test equals to train test split x comma y comma test base. Let's say I will give you, since it's a somewhat large data set, I will put here 0.7. So 70% of 0.3, sorry, 0.3. Yeah. So test size will be 30% of the entire data set. Okay. Let me put a random state equals to 42. It's nothing. You can just it's for the like we can just read it here for the what random state is. Extension controls the shuffling applied to a data before applying the split. Okay, it like it is to control the shuffling. For example, if I run this cell again, data set, the training and data set may change. Okay, different values occur in here there. So to stop that, random state is there. Okay, and 42 you can give it any variable. We just go with 42. So let's see. Yeah. Now we will be importing our model from sklearn dot uh, linear model import logistic regression, just like we did it with the linear regression in the previous lecture. So Now, I'm just giving the variable LOR and logistic regression LOR dot fit X train comma Y train. Okay. Now we will fit the dataset. Yeah, we have already fit. Ignore that. It's not an error. Okay, so the cell has run. That means we have fit the training and data set, training and test data set. Okay, now we will predict data. Sorry, we have fit the logistic regression on the training data set. Now we will try to predict. Okay, y pred equals to LOR dot predict. Uh, we will try to predict the X test data that we prepared. Okay, okay. There is small smelling error. Okay, let's go. So we have already predicted. Uh, date our prediction data would look like something like this. Okay, it's 0 and 1. Okay, now one more thing, like we were discussing about something about threshold. Okay, so threshold is the like we don't what we were saying, we don't like give it explicitly. We can, but generally the model itself uh, comes with a threshold, so we let it run on its default threshold. Okay, so we don't like set the threshold 0.5. It comes inside the model, and model uh, will also will will do the threshold part. Okay. now now we have y test just for yeah by red and white test. Okay, now what we will do is to uh, look into the accuracy, like how accurate a model has been trained. Okay, from sklearn dot metrics, we will import accuracy score. This will be a first metric. Okay, and accuracy score we will give by test and by prediction that the model predicted. Okay, y test is that we get from the data set, by splitting data set, and y pred is that the model predicted. Okay, so let's see. Okay, so accuracy score is given us the score of 86.0.86. That means model is 86% accurate. Okay, which is not like, it's a good accuracy, but not the best. Okay, we what we did is just directly applied our data to the uh, model. Okay, we can do many things like scaling and scale the values and use different columns, or and we can use heat maps and all that. But heat map again, but scaling and all that is beyond the scope of this lecture, so I'm just applying the entire data to it. So we can increase our accuracy. It's not like that, but the techniques may you may learn about that in the next lecture. Okay, so I'm keeping it that from the for the next lecture. Now there's another like performance metric, sklearn dot metrics import precision score. Okay, and we can also do recalls to score in the same, and also F1 score, since F1 score is a combination of precision and recall. Okay, I will explain it in a bit. Okay, so we can do print precision score. So precision score is like a matrix in which we calculate how much precise is our model. Like, is it able to actually able to, for example, what we are doing here is we took the data set of a we took some medical data set, okay, where we are trying to calculate whether the patient has a disease or not. Okay, now precision score is very important in that, to identify like whether the whether the patient has a disease or not. So precision score you will mostly is more accepted, or more you can say like some like precision score will give you a better picture in case of medical classification. Okay, so whenever you work with a medical classification precision score, you should definitely look into precision score, like what kind of precision score we are getting. Okay, y test comma y rate. Okay, so we will see like what is the precision score will be of this model. Okay, now we first of all we need to call recall also. Now recall score is also important, but in different test case scenarios, in different use cases. Okay, so recall is will be more important when you have to like you have to like detect a fraud. Okay, so like you have to like identify the fraud more of the time, because if you don't like uh, the fraud may get unnoticed and it will actually harmful. Okay, so in case of fraud detections, like whenever you work with whether it's fraud or not, or whether it's spam or not, recall score is like more preferred. Okay, and F1 score is like you can say is a weighted average of both precision and recall. Okay, I will show you the formula. Okay, so let me just write that print F1 score. Okay, so let me show you the formula of F1 score first. Formula of F1 score. Okay, so this is the formula of F1 score. 2 into precision into recall upon precision plus recall. Okay, so it is a, some kind of weighted average of F1 where both precision and recall are of equal importance. Okay, so let's see what where our model stand. Okay, so for precision score we have got 88%, recall we have 75, and total F1 score we will get 81%. Okay, so these are the score that we are getting. Now we can do like many techniques to improve our model. Uh, Basic what that like in that case, uh, it has a whole name called hyperparameter tuning, where we improve the performance of our model to the maximum. Okay, in that we will learn about like scaling, feature selection is also there. We can also do feature selection here, but it will take a lot of time. So that I'm leaving it for the if it's in the future lecture, I will leaving it for that. So now our model is getting this much accuracy on the go. We are not doing any kind of uh, hyperparameter tuning and all that. So from the get go, on just training uh, on the training on the data in the first time, we are getting accuracy and F1 all these performance around 80 to 88. Okay, so it is a good score, but can be a lot better. For that we may learn about that in the next lectures. Okay, so let's stick to go to the PPT and see what's next. So this is the process of how do we apply logistic regression in Python. Okay, model evaluation metrics that we did earlier: accuracy, overall correctness, we precision, like out of the predicted positives, how many are actual positive? Like out of the patients we identified will that have a disease, how many actually have a disease? Okay, and if recall, out of the actual positives, how many were correctly detected? Which means like the out of the people who have disease, how many did were correctly identified? You may get confused in the precision and recall sometimes. So basically, to understand, like for example, if we take like suppose we are identifying the whether the person has a disease or not. So precision would be like out of the predictive positives. Like if we predict like uh 10 people have disease. Okay, then out of those 10 people, how many people actually have a disease? Okay, like somewhat let's say we predict 10 these 10 people have a disease, and out of them 8 or 9 have a disease. So one is the person we incorrectly predicted. So 9 out of 10 out of 90%, we have a precision, a score of 90%. Okay. Now recall is like out of actual positives, like if in the patients, like out of 10 patients, 8 are 8 are those 8 are those who are actually who have actually a disease. Okay, who are actually like have some kind of disease. Then out of those 8, how many are the ones that we actually detected whether they have the disease or not? Okay, so for that we have recall score. Like out of 8, if we out of the 8 people that who have diseases, we predicted like out of those 8, 6 people have disease. So 6 by 8 into 100, whatever that will be, 3 by 4, 75% recall. Okay, that is the our recall score. Like out of the people who actually have a disease, we know that they have a disease. We are able to identify 70% of them. Okay, and F1 score. F1 score is like harmonic mean of or of precision recall. I already showed you the formula. It is 2 into mean into recall divided by sorry, I'm saying mean. 2 into precision into recall divided by precision plus recall. Okay, and we have confusion matrix. So confusion matrix is a breakdown of like precision and recall and F1 score into true positive, true negative, false positive, false negative breakdown. So let me like show you that from sklearn dot matrix import confusion matrix. All these performance evaluation methods you can find in sklearn dot matrix. Okay, so I will go confusion, right, in confusion matrix y test comma y red. Okay, now what it does give is a 2 by 2 array where we have true positive, which is very first value. We have true negative, which is second value in the first row, 3, and true negative, sorry, false positive, which is 8, first value in second row, and the last is 24, which is false negative. Okay, let me show you the confusion matrix. Okay, so this is how confusion matrix is there. Okay, on above you have predicted values where it belongs to the model. Okay, like model predicted yes or model predicted no, and actual values in the here in the you can say vertical. Okay, actual value which we get from the splitting our data set. Okay, which is basically test data set. Okay, so if the predicted and actual value is yes, it is called true positive. Like model predicted value, that is correct. Okay, and if the value which is yes and model predicted no, then it's called false negative. Okay, and if the actual value is no and model predicted yes, it is a false positive. Okay, and if the model correctly predicted the value no, which is actually also no, it is called true negative. Okay, and then around that you will get all your uh, precision recall stores, precision recall scores. Okay, so this is what a confusion matrix look like. Okay, let me find a better way to display the confusion matrix. Yeah. So this is what the confusion matrix is. So these metrics are critical for imbalanced data sets, which means like you have one category, like you have number of, suppose you have three categories, and the number of in the data set, like category one has more occurrence than category two and category three. Okay, so it is called imbalanced data set, where one category uh, has more amount of data as compared to other one. Okay. So we have reached the assignment. Uh, so we have to build a in this assignment. We have to build a logistic regression classifier using any binary data set, like I did with the medical data set. Binary data set means like there will be only two categories. In this, we have heart disease or any kind heart disease prediction. We have two categories, either presence or absence, one or zero. Okay, and for that, most of the time you get in that in a string, in a word, like whether hard is presence or absence. For that, you can do look into the net and you can use label encoder. Okay, here it is. I use already use this. You can use this label encoder. Oh, sorry, this is logic regression. My fault. Yeah, this is a label encoder. You can also look to the net how to do that. It is a two-line label encoder, and give it a and apply the label encoder to the target variable using fit transform and give it as another name and attach it to a dataset. There, that will become your uh, label dataset, target variable dataset. Okay, so you can use that label encoder. Okay, now what we will do is try to we will try to display the confusion matrix in this like somewhat under like so that we may be able to understand it better. So for that, okay, learn dot matrix import uh, confusion matrix display. Okay, and we will also import matplotlib. Import matplotlib dot pyplot splt. Okay, and we will go this is equals to confusion matrix display, and we will give it a confusion matrix that we created earlier. Okay, y test comma y red, and we will also use something called display labels. Yeah, display label, and we will give it a value of lor dot classes. It is lor dot classes is like if you remember correctly in the linear regression we learned about the slope and intercept, no? So it is somewhat similar to that. Okay. Now we will use this dot plot and plt dot show. So see, this is our confusion matrix where we have true label 1 and 0 and we have predicted label 0 and 1. Okay, so this one predicted label 1 and true label 1 will be our true positive. Okay, let me write it here in the comments, like true positive is equal to 24. Okay, and true negative is equals to true negative is where we predict the true label 0 as well as the machine is also predicting true label is 0. Okay, which is 46. And true positive, oh, sorry, true positive, false positive, which means machine is predicting the value to be 1, but it is actually 0, which is 3. Okay, and the false negative equal to where machine actually value is 0, but the machine predicting it to be 1. Sorry, machine actual present value is 1 and machine is predicting to be 0, which is 8. Okay, I hope I am right. Okay, so this is our confusion matrix. It is a little bit complicated. If you don't understand it, you can also read it on the net so that you can get a better understanding out of it. Okay, like we did here. Let me also check like whether I'm correct or not. One and zero. Here it is. 1 and 0 false negative. And I've given 1 and 0 false negative. Yeah, I'm correct. Okay. So this is how we like in the advanced use cases, you you may also get asked to increase true positive or increase true negative, like increase precision score or increase recall score. It is of advanced applications. So for now, you can just go with the accuracy score to predict the accuracy of a model. It will give you the like overall accuracy score. Okay, or you can go F1 score. It's okay, but don't let you confuse with the confusion matrix. Okay, so that's it for this lecture. Uh, thank you all for